Here are a couple of practice for the tic-tac-toe method, so hopefully you've had a chance to work through all 4 of these questions before watching the slideshow. For my first example, remember I'm always taking my first term and putting it in the first box and my last term in the second box, and then I multiply them to find the third box. Down below, I'm going to put the middle value, the negative 8x. Then I'm looking for numbers that multiply to 12, that add to 8, so that would be 2 and 6. Notice I need them to add to negative 8, so those will both be negative values. They still multiply to a positive, but they add to a negative. Now I know that this is going to be negative and this is going to be negative because of the 2 negatives here. To multiply to 2, it would have to be 1 times 2, and 2 would not be a factor of 3, and so the 2 must go here, which means the 1x is my first term. 1x times 3x would give me 3x squared, and negative 2 times negative 2 would give me positive 4, and then I double check that this direction also works, and it does, and so my factorization is 3x minus 2 and x minus 2. For my second example, again I make my tic-tac-toe. I put the 2x squared here and the minus 9, which gives me negative 18x squared, and I put my positive 3 down here. Remember, I'm looking for numbers that multiply to 18 that subtract to 3. So I would use 6x and negative 3x because their difference is 3 and they multiply to a negative 18. To multiply to negative 3, I would need 1 times negative 3. That means this must be a 2 because 1 times 2 would give me my 2. This must be a positive 3 because negative 3 times positive 3 gives me negative 9. And then I check this direction. 2x times 3 is 6x. Then I look at my diagonals for my answer. So x plus 3 and 2x minus 3. For our last 2 examples, we're dealing with a little bit larger of a number. And whenever we start, and I haven't done a very good job of reminding us of this every time, but you should always check for that GCF first. Looking at this first one, unfortunately, 7 is not a GCF because it does not go into 53, but you will want to look at taking a GCF out of our second example. So for my first, I've got 7x squared and positive 28, which multiplies to 196. X squared, and positive 53. Again, when we're trying to find those factors of 196, it's not a bad idea to just utilize your calculator. We want them to add to 53. And numbers that multiply to 196, obviously 1 and 196, which doesn't work, and 2 and 98, which doesn't work. But again, you can just use your calculator to take 196 divided by 2 and see what comes out. If I take 196 divided by 3, I get a decimal, so we know that's not going to work. If I take 196 divided by 4, it tells me 49, and those actually do add to 53. So it's going to be positive 4x and positive 49x to add to 53x and multiply to 196x squared. The 49 can only be 1 and 49 or 7 times 7, and obviously the 7 times 7 makes sense. This would have to be 1x, and this would have to be plus 4, and that makes all of my multiplication work. So my answer would be 7x plus 4 and x plus 7. For my second example, you can take out a GCF of 3. A lot of people would miss that. So let's go ahead and look at what happens if you don't take the GCF out of 3. If I don't take out that 3 at the beginning, then when I put this into my tic-tac-toe, I'm going to end up with some large numbers, negative 21 and negative 189. And down here I would have negative 60. And so I would be looking for numbers that multiplied to negative 189 that had a difference of 60. So again, you can make your little table. 189, we know they have to subtract to negative 60. And 1 and 189, clearly not going to work. 2, I don't even have to check because 189 is not even. 3 goes into 189 63 times, and those do have a difference of 60. So those are the two numbers that I will use. I want the negative 63 and the positive 3. So 3x and negative 60. Oops, 63. Sorry about that. Negative 63x. The 3 is difficult because I don't know if the 3 comes from the 9 or from the 21, and we're having that problem because he didn't take the 3 out at the beginning. But I can look at 63 and know that 63 is probably 9 times 7. The 7 is going to come from here, which means the 9 will come from here. So this is 9x times negative 7 to get negative 63, 9x times x to give me 9x squared, negative 7 times positive 3 to give me 21. And then when I write my factors, I get 9x plus 3 and x minus 7. Now obviously, looking at my first binomial, I notice that they both have a common term of 3 that I could take out of them. So if I take a 3 out, the 3 goes out front. That leaves me with 3x plus 1 and x minus 7. So the preferable way is to take the 3 out at the beginning. If I took a 3 out of all of the terms, this would not have been as difficult to find those numbers, and I would have still ended up at my final result.